Okay, so we've asked a lot of questions, a lot of questions, a lot of wondering we're doing. Okay, but what if there was a theory out there that could answer all of this? And keep in mind, the simplest theory explaining the most details is probably correct. When you have a theory, I mean, most theories go from we know what the effect is, but we don't know what caused it. We know the effect, but it's an unknown cause. This is different. He sets up the cause with only one assumption, and then he lets the laws of physics go at it and gives us the effects, which are perfect. And I gave this book to there was a geologist at our college at St. Cloud State, and I told her, you don't have a theory that works for Grand Canyon. Do you want to see one that does? And she was curious, so she took the book and she went through it. She had it for about 6 months, and we finally got down, we got together and we talked again. And she said, if the assumption is true, the science works. She just did not believe the assumption was true. So the fewer the assumptions you have, the better. The more predictions you can make, the better. Okay, and I wish that we could save a lot of time with these theories if they couldn't publish their theory until they made an accurate prediction. That would save us a lot of time and a lot of money. But she said that if the assumption's true, what I'm about to show you is valid. Okay, and so what's the assumption? Basically, just picture the Earth as a big apple. The assumption is half of the Earth, or half of the ocean water was inside the Earth, roughly a mile, or roughly 60 miles deep. It was about a mile thick. And so just think of the Earth as a big apple. The skin is 60 miles thick, made of granite. And then there's a layer of water underneath it. That's water, about a mile thick. And then underneath that is basalt. And the granite and the basalt are touching each other at thousands of places underneath the Earth. They call it, Walt Brown calls them pillars. Okay, so that's the one assumption. How it got there isn't part of the theory, but that's the one assumption. Okay, so now let's let the laws of physics go at it. You throw in the moon, because the moon's gravity tugs on the Earth twice. You get high tide twice a day. High tide and low tide, it's tugging on the Earth. It's going to tug on the crust too. And back then, the crust wasn't broken into plates like it is today. It was just the crust. So it stretched and compressed, stretched and compressed, stretched and compressed, and that added heat. It got hotter and hotter. And so the heat went into the water. And water will boil at 212 degrees at sea level. But what if you plug it up and add the pressure and just keep adding more and more heat? Eventually it becomes supercritical water. And that's what happened inside the subterranean water chambers. It wanted to boil, but it didn't have any room to expand. And so this is when liquid density and gas density are equal. And that happens at 705 degrees Fahrenheit under 3,200 PSI. It's supercritical, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So now it starts to dissolve the granite above and the basalt below, and starts to make these elements like limestone and salts and quartz. And that's how you made the limestone, because now when it's making an element of carbon dioxide, it's getting recycled. It's not going up into the atmosphere. It's getting recycled into something else, and then it turns into limestone. It gets recycled and turns into limestone, and that's how you get all the limestone. That's where you get a lot of this sediment too, and the cementing mixing agents are also being formed in the subterranean waters. And if you want to see more of that, Brian Nichols spoke at our Creation Club. We get a Rumble channel. Go into Twin Cities Creation Science Association on Rumble, TCCSA, and he does a great job. Or you can go into his YouTube site too. And so what's happening here? Now, a lot of those salts, a lot of those minerals, and it's getting hotter and hotter. It's getting warmer or weaker and weaker. It's dissolving the crust. So the crust is getting weaker and weaker. And eventually, there's a crack in the Earth. It erupts to the front, erupts to the top, okay? And it's going to crack the Earth, and it's going to go around in two directions at 3 miles per second, and in 2 hours, it encircles the globe. And the water, which is now under 60 miles of granite, plus all that pressure and heat, it's under 370,000 psi. So it erupts to the surface. And just to think of what water can do, keep your eye on the dumpsters. See what's going to happen at the dumpsters. Boom, that's just one water vein. Can you imagine what was happening if the whole Earth did that? And the Bible tells us in the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were the bones of the great deep broken up and the windows of heaven were open. So that's what happened and when it happened. That's how you can get, and the water's erupting up. So that's how you can get 40 days and 40 nights of rain. Okay, and people say, well, if that happened, wouldn't it leave a mark on the earth? And the answer is yes. The mid-oceanic ridge, that's that crack that's going through the oceans there. That's the mid-oceanic ridge. That's where the fountains of the great deep broke up. And I'm not sure if you can see that circle on the right, but that's where he thinks that it ended. And so you run the movie backwards, he thinks it started up by Alaska, and then it just went all the way around. Then when it came together on itself, it stopped. And the water is just erupting out of there with tremendous force, tremendous pressure, and it just keeps going up. And so, right, it's raining for 40 days and 40 nights, and then it gets enough water where it covers the fountain and it can't push it up anymore. But the Bible says it keeps going up for another 110 days. So that's where the water came from. It came from inside the earth, and we'll talk about where it goes, where it went. But now keep in mind, now we got two 60-mile cliffs. And on earth, you can only have a cliff 5 miles high before it crushes the rock below and it crumbles. So now you got two 60-mile cliffs, and they're crumbling. That granite's crumbling into that flow. And so that's where a lot of the sedimentary rock came from, was from the granite that got eroded away from the Atlantic Ocean and the basalt underneath. That's why the ratio is 65 to 35. Okay. And that's how you get these layers here all over the continent. But what sorts them? How come they're so pure? And the mega sequence, I submit liquefaction. That's what Bob Enyart told Tim Clary. How do you get those layers? Liquefaction. You got these big waves going around the earth that pushes a lot of pressure down into the sand. And then when they go by, that pressure is released, and it just keeps going back and forth and back and forth. And that can sort things by their density. And this is a flume, a liquefaction at a flutter place. So that can do it. And so now you got all this stuff crumbling into that flow. These two cliffs are getting wider and wider apart. And pretty soon there's nothing pushing down on that mantle. And so the mantle bulges. That's how you get the mid-oceanic ridge. It bulges, stretching it in two directions. And so now it's like lifting up a train track. The train's going to start rolling. So that's what happened. The continents start sliding, and so there's even less weight on the mantle, and so that it bulges even more, and there's less, and it bulges even more. So you got North America and South America going to the west, and South and Africa and Europe going to the east, and they keep going until they meet resistance. And that's why their missing crust is in the mid-Atlantic. It either eroded away or it slid away. That's startling, they say. And that's why, they keep going until they meet resistance, and then they buckle up. Like if a rug going into a carpet, a wall or something's going to buckle, or a car accident, the hood buckles. That's what happened to the plates. They buckled. And that's why the mountains are mainly parallel to the mid-oceanic ridges. And this over here, the Andes are half as big as the Rockies. And I think that's because the plate slid over the mid-oceanic ridge. And when it slid together, there's a lot of force, there's a lot of heat, there's a lot of pressure. And that's where we get our coal and our oil and our metamorphic rocks like marble and diamond. And those things still have carbon-14 in them. So they're not millions of years old. They find carbon-14 in everything that they shouldn't find it in based on that evolutionary theory. And this is, I think, in British Columbia. These are mountains that had to be soft, pliable mud when it was pushed together because there's no cracks there. They got pushed together. And you can do an experiment at home. Take your finest china and bend it. See what happens. See if it'll crack or see if it'll bend. And these are compression cracks. We had talked about tension cracks, which are straight. These are compression. This is Gunnison Canyon in Colorado. They got crushed together, and as the rock's crushing, the quartz in it melts and fills up those little lines. And it's really hard to do. Okay, and you get the same type of rock, these quartz-filled cracks in crystalline rock, the same things at the inner gorge. Something crushed. I mean, a lot of force was used. And so that's how we get the mid-oceanic ridge stretched in two directions. Okay, so now how do we get plateaus? Remember that double-ended mystery? It grows up and down at the same time. What force would rise it? It's hydraulics. The mountains rose up, so you got a big mass on a small base and it sinks in to the mantle. Well, if something sinks in, something's got to rise up, and that's where the plateaus came from. What's the force? And it's hydraulics. And it just breaks out the plateau, and then the force is released, and then more builds up, so the plateau gets raised piece by piece. Okay, so it's gravity. All right, and so what's going to happen? There's going to be a lot of pressure there. The granite's going to be melting. It's going to be turning into lava. The lava is going to go up onto some cracks, and you're going to have lava on top of the soft sediment, and a big wave. Water comes flowing by. It's not gonna eat into that lava. It's going to go around it. And that's how you're going to get something like Red Butte, which is downstream from the Grand Canyon, or it's in that same area. Okay, so again, similarly, if something's going up, something else has to go in. The mid-oceanic ridge is rising throughout the Earth, so something has to get sucked in, and that's the Pacific Ocean. That's why you have the ring of fire, all that lava, all that instability. That's why the trenches are in the Pacific Ocean. And this is, if you get a ping pong ball and you push it together, it's going to be kind of like the Pacific Ocean. It got sucked in. And you got the the trenches, Mariana Trench. You got all those volcanoes in the Pacific Ocean. That's why, because it got sucked in. Tremendous pressure, tremendous heat. And Walt Brown said you should find some granite in the Pacific Ocean if his theory is true. And guess what? They found Zealandia, the eighth continent. And it's about the size of India. It got sucked in there. They find fossils of land animals, and that's got sucked in. According, you would expect that if this theory was true. And okay, so now this stuff is going up and going up, and at the end of the cliffs, at the end of a nozzle, there's more pressure, so there's going to be more erosion there. And keep in mind, those things are going to be slamming up and down too, which is going to cause more erosion. That's how you get the gradual continental slope and the continental shelf. That's what happens there. That's how that came about. Okay, and how do you get the submarine canyons? Well, Walt Brown says the continents were higher back then, and the water gushed off to fill up the Pacific Ocean. So it cut those canyons when the continents were higher, and over time the continents sunk in, the oceans rose up, and the water table buried those canyons. Brian Nickel does a great job too animating it. Go into YouTube, Brian Nickel. He gave me a lot of these slides. I get a lot of information. He's got the best Grand Canyon video I've ever seen, and I've seen a lot of them, and just a top notch. He knows this probably just as well, almost as well as Walt Brown. And I encourage you to check that out or buy his DVD, because they can shut down YouTube anytime they want.